Hello and welcome back to the Blade of Akai channel. You are watching Shenzhen IO, and in the last episode we made an infrared sensor and a virtual reality buzzer. So we are now moving on to the next design. So what's this? Sometimes prototyping new ideas. This is sometimes a decent product idea falls out when you're faffing about with chips and code. Empty prototype board for us to experiment on. On you go then. We can test with different parts. Oh, this is an electronic game that I've yet to finish doing. Okay. I'm pretty sure I looked at that already, what the things visitors say. So let's go on to this. Wireless game controller. Carl Teskey, I'm wrapping up a project to make a game console and could use some assistance. Before you get too excited, it sounds far more fun than it actually is. The console is just a tiny super cheap box we're making for Sleep Cubes, the big Japanese capsule hotel chain, to stick in every pod. The games will just be some free dross they find, I'm sure. At any rate, I've got it mostly done. I just need a module for the little wireless controller that comes with it. I ping you, you tell me what's going on. Nothing much more than that. Okay, let's get in. So wireless game, let's do the rename now. WGC D1. Terribly interesting names. Right, open design. What are we going to do here? X and Y are simple inputs connected to a joystick over on the left, which you can't see because you can't see the mouse cursor for some reason. So down here, X and Y. A and B are simple inputs connected to buttons. A and B over here. Okay, radio RX is a non-blocking X-bus input connected to a radio receiver. Radio TX is an X-bus connected output connected to a radio transmitter. So that's TX and RX over here. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure to use the most recent input values. Okay, 3. Oh, I see. 40, 60. Oh, alright, okay, I get it now. We're sending X, then Y, then this state, according to A and B. Right. Okay. Now, I guess the first thing we need to tackle is this state machine down here. Part not recommended. Right, are these... Let me just check. Are these pins? Yeah, those are pins. Right, okay, we're going to need, I think, at least this, if not the bigger part, but let's just go with this for now. And then, I mean, essentially I just need one output from this with this state in. So I wonder if let me think. Right, we've got right, so if I just do this, right, if I move P1 to ACK straight off the board, off the mark even, and then move, then add P0. Let's do this the other way around. So P0 to ACK, then add P1, right? And then we can test if ACK is equal to 0. If it is, then we're moving X. We're moving 0 to X0. This might not be the final logic, obviously, but X0. Okay. Otherwise, if what we can then say, let me think about this a minute. Right. I think I might need more instructions to be able to achieve this, but let's just get it down just so I can get it out of my head. If ACK equals 200, move 3 to X0. I mean, essentially we would need to jump to end, and that would be sleep 1. Yeah, I don't think I've got enough instructions to do it this way. I wonder if I can do this by doing some tricky maths to kind of fake 0, 1, 2, 3. So if I said move P1 to ACK, then multiply ACK by 2, right? That would give me 200 if it was 100. If otherwise, it would be 0 still. Then I can add P0. Yeah, then I can add P0 and then I would have to do some kind of odd sorry, it's getting some things wrong there. So multiply by what? Because I don't think, yeah, div's not an operator, is it? It's not. But I basically would need multiplied by 0.01, but that's not right. How? Oh, I don't need to do that. I can just take the digit. The digit, right. Where's the digit? Yeah, just DGT. So if I just take DGT 0, 0 is to the far right, 1 and then 2. So it would be digit 2. If digit 2 doesn't exist, then the whole lot is 0, right? So then I can move ACK to X0. That should give me my state. Now let's just shrink that down a little bit and just do this as a test circuit. Can I not right, basic errors, sleep 1, heart not sleeping, blocked. What? Blocked on right? Why is it blocked on right? Oh, right, I think I put them in the wrong place. So go to the TX. There we go. Right, I can't see what the actual value is. Expected 60, actual 2. Expected none, actual 3. 3, 3. I think it's kinda there. So now I need the circuit that does the other piece that passes through this. So I don't know if I can do it with one here, but let's just try and spec it up this way anyway. Right, so we should literally just be passing this through, right? So move. I wonder if move X then Y, isn't it? So move P0 to X0, sleep 1, move P1 to X0, sleep 1, NOP, sleep 1, right? And then I wonder if then I have to see that's 1 2 3 4 5 6 1 2 3 4 5. Well, it's kind of 6 operations, but I don't think that's right. So some of the values are right. Yeah, if I sleep on X0, oh, I can't type at all. Right, X0, there we go. And then over here, I'll need to do something with it. If I just move X0 to AC, because I don't really care what the value is. Then I can literally, when I'm in this part of the logic, I can just move 1 to X2. I do it after those reads, and then I can sleep on X2 waiting for the response to come back, and then hopefully that's gonna do what we need it to do. Look at that. It's a thing of beauty. That's awesome. I was hoping it would be fairly simple. I was kind of expecting to have to go over this a few times. Awesome. Power usage. Yeah, power usage isn't so fantastic, so there must be a more efficient way of doing this. Right now I don't know what that is. Yeah, I'm looking at this and I can't. I'm pretty sure the test over here, if I change this move X0 to the accumulator, if I change that to a test, it's going to use even more power, if you ask me. Right, I probably need to play with that later on. I think what I'm probably going to do is I'm going to go back over these bits and bobs, these designs, and going to show each one optimized as best as I can do it, but right now I'm kind of happy with where this is. What I'm going to try though is going back. Yeah, it's remembered all of that. Hey, thanks mate, I owe you one. You've just helped make thousands of dead tired salarymen marginally happier. That is, if they actually find the console and use it to play a game before passing out. Okay. Feel the connection and get ahead. Your virtual friend. Are you lonely? Do you feel isolated and disconnected from the world? Scientists have shown that a lack of real-life ties to others can lead to depression, which in turn can negatively affect performance at work. Don't let the lack of human interaction reduce your effectiveness. Virtual friends from BuddyBots are quality friends nearly indistinguishable from real-life people. Our characters are developed by the world's top personality designers and are completely customizable. So whether you want a supportive presence to help you through a difficult time or a flirtatious sidekick to banter with throughout the day, you're covered. Subscriptions are flexible and competitively priced with other bot companion services. Stop being lonely, feel the connection, and become a top contributor to your company's success. Wow. Okay, moving on to the next device. Device 2A27. What's that mean? Unknown optimization device. Poseidon 779. Poseidon 779, a decentralized autonomous corporation, has determined that thorium mining operations can be optimized by as much as 2.7% by creating a device with certain specifications. The specifications are included in this communique. Please create 50 of these devices and ship to 101 Jibajiao Road, Shaibak, Urumqi, Xinjiang, China, 830054. Payment will be forwarded upon verification of completed work. Joe saying, what is this? And Lily Wu is saying, a decentralized autonomous corporation is a company run without human involvement. It has money and investors, but it makes decisions for itself on what to do with that money using information from multiple lower-level monitoring and analysis programs. Some of my classmates were studying them when I was at Princeton, but lately the hype died down somewhat. I guess there are some still operating now, maybe even doing well. Why don't we do the job for it and see what happens? And G is saying, I made a copy of the specifications it sent. It's on your desk. Okay, let's take a look. So it says unknown at the top. I'm going to use TMOD D1 for a thorium mining optimization device. Right. X and Y are simple inputs connected to an unknown device, presumably some type of position sensor. Power is a simple output connected to an unknown device, presumably some type of motor or high power switch. Map the XY coordinate to the corresponding power value as specified in Poseidon 779's geometric specifications, which can be found in the supplemental data section of the manual. Okay, I've got to read the manual. So we've got this Y input here, which when it gets to 59 is maybe doing something, or when this gets to 45 is doing something. Then it steps up a little bit, comes back down. Okay, it's saying an awful lot of those parts are not recommended. What's this thing here? Note. I think this is new. There's been an update. I think there's been an update recently, so that is a new part. I think a lot of this stuff is new, to be perfectly honest with you. But it's just all of a sudden started appearing. Right, so documentation. Okay, I've found the document, and hopefully I'll put an overlay on the screen. But it says this is a geometric visualization of a state space. The 2A27 actuator control must take a value as shown in specifications dependent on inputs as described. So if x is less than 20, power should be 30. If x is greater than or equal to 40 or less than 80, then it's in a square box where there's a value of 50 or 80. If x is greater than or equal to 60, it could be 30. That's kind of a confusing overlap. And then if y is greater than or equal to 40 and less than 80, it's in the box for 50 or 80. Okay, so I've got to figure out what the logic is going to be to meet that specification, basically. So finally I came up with this design, and thankfully it only uses 2 boards. It's a bit messy logic wise, because basically I'm checking for something greater than 39 and something less than 80 in 2 different locations, which, you know, you'd like to think you could kind of farm that off to another process in an efficient manner, but it doesn't really work in this. So basically we receive the X signal, and you know, whether it's greater than 20 or not, we then check whether it's less than 60. If so, we just need to send out 0 because that's in the dead zone. And then we need to check whether we're in the kind of hot zone for this kind of block that sits in the middle, where we're either sending 80 or 50. And then what I'm doing there is I'm just saying I'm just moving 1 to x1 if we're in the sweet spot, or 0 to x1 if we're not. And using that signal on the Y, I'm then understanding that signal that's coming in from the first board, and then basically if it equals 0, just jump to the send, and then I'll move whatever's in the accumulator out to P1. Otherwise we will check whether Y is in the sweet spot. If it is, we'll just add 50 to the accumulator. Basically what's coming in through X0 is basically X0 is the voltage for the pin, and X1 is the signal of 1 or 0. So yeah, basically we're moving the voltage from the X circuit into the accumulator, and then we're literally just going to add 50 to it if we're in that sweet spot, and then move everything to P1, which powers our device. So this should give us some success finally. Let's just watch this go through. Speed it up a little bit. The power usage is a bit on the high side though, for something that is effectively quite simple. However, we're into 6 yuan in cost, and yeah, about the 700 mark for the power, which puts us pretty much where everyone else is. I don't know how this person or few people have achieved this, but there must be a way. Anyway, let's return to email. Task verified complete, payment en route. This is from the computer. And then Carl says, what a future we live in, eh? And Joe says, that was cool. Yeah, this guy is just so over optimistic about everything, it's painful. Anyway, I'm done for this episode. I hope you enjoyed it. If you did, don't forget to hit like, share and subscribe, and I shall see you all in the next episode of Shenzhen IO. Thanks for watching, and bye bye for now. Human hack. What? Are you, what? What the hell? What the hell? O2 supply activated. Acceleration.